Hi there, Miss Barber here. This lesson is titled Measures of Dispersion. Measures of dispersion, such as the range and standard deviation, are numerical values that describe the spread of data. To see the importance of measures of dispersion, let's compute a couple of measures of central tendency for the following 4 data sets. Discovery activity. Find the mean and median of the following sets of data. A, 50 and 100. Let's begin by finding the mean. The mean is the sum of the data items divided by the total number of items. For this set of data, that'll be 50 plus 100 divided by 2. 50 plus 100 is 150. We still divide by 2, that's the number of pieces of data, and the quotient is 75. Let's find the median. The median is the value that corresponds to the middle position of the data when it is in order. Since this data set only has 2 pieces of data, it's going to be the same thing as the mean. We'll have 50 plus 100 divided by 2. The sum of 50 plus 100 is 150. 150 divided by 2, the quotient is 75. Part B. Data set 50, 75, 100. Let's find the mean. The mean is the sum of the data items divided by the number of items. In this case, we will have 50 plus 75 plus 100, and we divide that by 3 because there are 3 data items. That would be equal to, and the sum of the items in the numerator is 225. We divide that by 3. The quotient is 75. Let's find the median. The median is the value that corresponds to the middle position of ranked data. This data set has 3 items. The middle position is the second item, and the value of the second position is 75. Thus, the median is 75. Data set that corresponds to C. We have 50, 75, 75, 75, 75, 75, 100. Let's find the mean. The mean is the sum of all the data items divided by the number of items. Let's write that out. So you take each of those data items, add them together, and divide by 7. That would be equal to the sum of the data items is 525. Divide that by 7, the quotient is 75. We still need to find the median, and the median is the value that corresponds to the middle position of ranked data. This data set has 7 items. The middle position is the 4th item, and the value of the 4th position is 75. Thus, the median is 75. Part D, the data 50, 60, 65, 75, 75, 100, 100. Compute the mean. The mean is the sum of all of the data items divided by the number of items. There are 7 items. Let's add up each of the data items together. The sum is 525, and we'll divide that by 7. The quotient is 75. Now we need to find the median. The median is the value that corresponds to the middle position of ranked data. This data set has 7 items. The middle position is the 4th item, and the value of the 4th position is 75. Thus, the median is 75. Let's make a quick observation. You are presented with 4 rather different sets of data, and all of them have the same mean and the same median. These measures of central tendency did not give us much information at all about the spread of the data. Definitions. 1. measures of dispersion are used to indicate the spread of data. 2. The range is the difference between the highest and lowest values. It indicates the total spread of data. To compute the range, you would find the difference of the highest value and the lowest value. For the previous discovery activity, compute the range for each of the data sets. We'll begin with A. The range is the difference between the highest and the lowest values. So in this instance, it'll be 100 minus 50, which is 50. Part B, we need to find the range. The range is the difference between the highest value and the lowest value. So that would be 100 minus 50, or 50. Part C, we need to find the range. The range is the difference between the highest and the lowest value. And so again, we have 100 minus 50. The range is 50. Part D, we need the range. The range is the difference between the largest value and the lowest value. So in this instance, we'd still have 100 minus 50, which is 50. Let's observe that for these four rather different sets of data, we have three generalized pieces of information which are exactly the same. The mean and median, those are measures of central tendency, are all the same, and the range, our first measure of dispersion, still the same for all four sets of data. Standard deviation. The standard deviation measures how much the data differ from the mean. The notation is S when used to calculate for a sample, and lowercase Greek sigma when used to calculate for a population. The formula is S equals the square root of the quotient, and in the numerator, the summation of the quantity x minus x bar, all squared, divided by n minus 1. That's a little intimidating looking, but let's look at the steps for computing the standard deviation. Step 1, find the mean of the data set. Step 2, make a chart or table with 3 columns. We need the columns to state data, data minus mean, and the quantity of data minus mean squared. We need to list the data vertically under the column labeled data. Next step, subtract the mean from each piece of data and write the difference value in the data minus mean column. Square the values obtained in the previous step and write the squares in the data minus mean quantity squared column. Compute the sum of the values in the column data minus mean quantity squared. Divide the sum of step 6 by n minus 1, where n is the number of pieces of data. Compute the square root of the number obtained in the previous step. This number is the standard deviation of the data set. Let's do this. Example, the following are prices of selected washing machines on sale at a local appliance store. The prices in hundreds of dollars are $4.99, $2.49, $7.19, $6.84, $9.89, and $2.99. Part A, compute the standard deviation. We begin by computing the mean. To compute the mean, we need to add up the prices of all of the washing machines and divide by 6. The notation would be x bar equals the summation of x divided by n. That would be equal to $4.99 plus $2.49 plus 719 plus 684 plus 989 plus 299, and that sum divided by 6. That's equal to, the sum is 3,439. We divide that by 6, and that quotient is approximately 573.1667. Because we're working with money, let's round to the nearest dollar and use $573 for the mean price of these selected washing machines. Now the standard deviation table. Recall, we just computed the mean. X bar is equal to 573. We have the table. The first column is data, and we have the 6 prices of those washing machines in place. The column to its immediate right is data minus mean. We're going to compute that. Get your calculator out and do this with me. The data is 249. Subtract 573. The difference is negative 324. We'll do that again 5 more times with the 5 remaining pieces of data. 299 minus 573. The difference is negative 274. 499 minus 573. The difference is negative 74. 684 minus 573. The difference is 111. 719 minus 573. Use your calculator. Do this along with me. The difference is 146. And finally, 989 minus 573. That difference is 416. Shifting over one more column to the right, we have a squared in the data minus mean in parentheses. So use your calculator, key in negative 324 in parentheses and square it. The squared value is 104,976. Square negative 274. The square is 75076. Square 74. The square is 5476. Square 111. The square of 111 is 12321. Square 146. The square of 146 is 21316. And finally, square 416. And the square of 416 is 173,056. Now the summation symbol, that means we need to add up everything in the third column to give us the total. And the sum of those 6 numbers is 392,221. Let's remember that. The total, the sum, is 392,221. That number will be important as we continue to find the standard deviation. To get the standard deviation, we need to look at the formula, which was S equals the square root of the summation of, in parentheses, x minus x bar, and that square, all of that divided by n minus 1. We've actually computed the number that should replace the summation of x minus x bar squared. That was the 392,221. Still needing to complete the formula, we had 6 items, so n equals 6. Then n minus 1, which would be 6 minus 1, would equal 5. Let's put our numbers into the formula. So under the square root, in the numerator, put in 392,221. We want to divide that by 6 minus 1. You could have just as well written that directly as the square root of 392,221 divided by 5. Use your calculator to get the quotient of the numbers under the square root, and you'll get that the quotient is equal to 78444.2. Use the square root feature on your calculator. That's approximately equal to 280.0789175. The standard deviation is $280 and about 8 cents. Don't you agree that this was a tedious set of steps? Fortunately, your TI-84 has a feature that lets you compute the standard deviation pretty straightforward. So let's work on learning those keystrokes. This is the screen of a TI-84 Plus CE calculator. We're going to learn how to find the standard deviation using this tool. To begin with, find the STAT button, S-T-A-T, and select it. When the screen pops up, you want the edit. That's the default screen that pops up. So click Enter. Now you have some columns. Under the L1 column, put in the prices of our washing machines. I'll start with $4.99. Press Enter. $2.49. Press Enter. $719. Press Enter. $684. Press Enter. $989. Enter. And finally $299. Enter. Check the numbers, make sure they're correct. Now you have your data stored into your calculator. We want to get out of the screen, and to do that I want to quit. So hit the blue second and the button right next to it which says Mode, and that lets us quit. Next we're going to find the standard deviation. Go back and click Stat again, but this time we want to calculate something, so scroll to the right and pick CALC. The default is the one variable stats. That's what we want. Select Enter. The list one is what we want. Just continue to enter to calculate. And now look at what the screen shows. It even gives us the mean, the X bar, 573.1666667. And look towards the bottom where you have the capital SX. That gives us our standard deviation that we just computed, 280.0788579. This is a very powerful tool. Be sure to practice it. Now compute the standard deviation on your technology tool for each of the data sets of the discovery activity. You'll check your answers with mine. Part A. We had a mean of 75, median of 75, range of 50. We want the standard deviation. Compute this in your calculator and check with me. You should have 35.355.33906. For the data set consisting of 50, 75, 100, compute the standard deviation using your calculator. You should have 25. Data set for C. The mean was 75, median was 75, range is 50. Now compute the standard deviation using your calculator. The standard deviation you should have 14.43375673. Data set for D. The mean was 75, median was 75, range is 50. Compute the standard deviation using your calculator. You should have 19.14854216. Please take a moment to notice that for these four very different sets of data, the mean, median, and range were all exactly the same. The distinguishing number came from the standard deviation. Example, I have two routes that I use to drive to work. One route is through town and has a lot of construction and traffic lights. The other route is primarily the interstate, but it is a longer distance. Even so, the two routes take about the same amount of drive time. Which is likely to have a higher standard deviation? The drive through town is likely to have a higher standard deviation because it has more opportunities for deviation. You've got traffic lights, and construction, and they all introduce the possibility of intermittent disruptions. Example, the mean difference between the midterm exam grade and the final exam grade was -7 for an entry-level math course. The -7 mean difference means that the final exam's mean was 7 points lower than the mean of the midterm. Part A. If the SD for the difference in scores is 1 point, what does that suggest? The standard deviation of 1 suggests that the difference in scores between the midterm and final was mostly consistent. Generally, students scored between 6 to 8 points lower on the final than on the midterm. That's within 1 point of the mean difference of -7. Part B. If the standard deviation for the difference is 1, would it be surprising to find that a student scored 20 points higher on the final exam? Oh yeah, if a student scored 20 points higher on the final exam when the mean was 7 points lower, that is a 27-point deviation. It would be very surprising. Part C. If the SD for the mean difference in scores was 15 points, would it be surprising for a student to score 20 points higher? Not too surprising. If the standard deviation of the difference is 15 points, then the 20 points higher score is within 2 standard deviations. So again, not too surprising.